In this video, we're going to look at complex numbers. Complex numbers are numbers that use I, where I is the square root of -1, and also I squared equals -1. And you might be asking, why have such a number? Well, for one, just to solve the equation x squared equals -1, we need I. The solution of x squared equals -1 would be x equal I or x equal -I. Also, if we solved a quadratic equation and we got the solution x equal -1 plus or minus the square root of -7 all over 2, we need some way of expressing that square root of -7. I gives us a way. We can rewrite square root of -7 as square root of -1 times 7, and then break that up and write it as square root of -1 times square root of 7. Well, the square root of -1 is I, so we get I times the square root of 7. So our quadratic solution can be written as x equal -1 plus or minus I square roots of 7. In general, we can rewrite any square root of a negative as I times square root of a positive. So for example, square root of -3 would be I times the square root of 3. Square root of -13 would be I times the square root of 13. The standard form of a complex number is a plus bi, where a is the real part and bi is the imaginary part. And here are some examples. The complex number 2 plus 3i has a real part of 2 and an imaginary part of 3i, and it's in the form a plus bi. Another example is just the number 4. 4 is actually a complex number, but also a real number. It has a real part of 4 and an imaginary part of 0i. We also have the example 5i. We call 5i a purely imaginary complex number. It has a real part of 0 and an imaginary part of 5i. All three of these are complex numbers. Only the middle number is what we call a real number because it has a 0 imaginary part. All the standard properties that apply to real numbers, like the distributive property, commutative, and associative properties, also apply to complex numbers. This means you can use the following simple rule. When performing operations with complex numbers, treat the I like any other variable, like an x, for example, except replace any I squared with -1. And we'll go through a few examples on the next page. In the first example, we're going to multiply out the complex numbers 3 plus 2i times 5 minus 6i and write the answer in standard form. We'll multiply this out just as if we were multiplying 3 plus 2x times 5 minus 6x. We just FOIL this out, or use the distributive property, multiplying out 3 times 5, 3 times minus 6i, 2i times 5, and -2i times 6i. And we multiply out these terms, we get 15 minus 8i plus 10i minus 12i squared. Now we see the I squared showing up here, and where the I squared is, we replace it with -1. And after we simplify and combine like terms, we end up with 27 minus 8i, or we can also write this as 27 plus -8i, and either of these two answers are considered standard form of the result. In the next example, we're going to multiply out 3 plus 2i times 3 minus 2i. Here we distribute out the products, or FOIL them out, and after we do so, the 6i terms cancel and we end up with 9 minus 4i squared. But the I squared turns into -1, so we end up with 9 minus 4 times -1, and that turns into just 13. You notice the I terms have disappeared. And this is always going to happen when you multiply a complex number by a similar complex number that has a minus sign instead of a plus sign. And that similar complex number is called the complex conjugate. For any complex number a plus bi, the complex conjugate is a minus bi. And when we multiply a plus bi times a minus bi, we always end up with a squared plus b squared. the a, b, I terms cancel and the I squared turns into -1. We can use this fact to divide complex numbers. In this example, we're going to divide 3 plus 2i divide by 4 minus 3i and write the answer in standard form. The first thing we do is write this division as a fraction. Now, if we multiply the denominator by its conjugate, the denominator is going to turn into a real number. And we can do this as long as we multiply the numerator by that same conjugate. So that's what we do here. We multiply both numerator and denominator by 4 plus 3i. And when we do that, we FOIL out the terms in the numerator, and in the denominator, the 12i terms cancel each other, and after combining like terms, we end up with 6 plus 17i in the numerator, and just 25 in the denominator. And now we can go one step further. Our single fraction is not really in standard form, but we can split it up into two fractions and write it as 6/25 plus 17/25 I, and this gives us our standard form of our complex answer. With respect to complex numbers covered in this course, there's just 3 things to remember. Number 1, replace every square root of a negative with I times the square root of a positive. You'll do this when you write answers of quadratic equations that you solve. Number 2, when you're doing operations with the complex numbers, treat the I just like an x, except replace each I squared with -1. And number 3, if you're dividing complex numbers, like in the example above, multiply both the numerator and denominator by the conjugate of the denominator, and then simplify it.